Team, welcome to day two of the Agent Architect live cohort. And today we're going to be looking at the concepts, all those, I would say, aspects that make an agent an actual agent, right? So we saw about how LLMs are like water and agents are like bottled water, where you're able to um, reinforce how an LLM should behave. And the most important aspect of making an LLM work like an agent, um, or the knowledge bases that you attach to an agent, the tool calling feature that you have with an agent, right? These are the two aspects literally that makes an LLM far more useful and agentic. And today we're going to we'll go deeper into what is knowledge base, retrieval, vector databases, various RAG. RAG stands for Retrieval Augmented Generation. What are the various RAGs? What seems to be really working in production? And we'll share with some really strong examples. And also, we will look into tool calling and MCP and A2A, and finally, move into voice agents for the day. So that's the spread for the day. And tomorrow, and because today we're going to cover all the theory part, and tomorrow we are getting into orchestration, where we will build these orchestrations in real time. So with that, let me share my screen. Here we go. So today we're going to dive into knowledge base and tools, and we will cover agents. Yesterday we saw LLMs and agents and what is software 3.0, the difference between agentic AI and AI agents. But today we're going to go deeper into RAG, vector databases, graph RAG, agentic RAG, and also look into tool calling, MCP, and finally the voice agents. And there'll be a split screen where we'll also show you how to build it on Lyzr, how we made it super easy for anyone to build it on Lyzr. But before that, let us look into autonomous agents, right? So, kind of an emerging concept. Autonomous agents are nothing new. Think of a simpler example would be lead enrichment. Imagine if you get an inbound lead, say on your company's book a demo form. You have an agent that will automatically pick the lead, enrich the lead by looking into Clay or Apollo to identify, okay, who's the person? Are they a decision maker? Are they from a large company, or probably the segment that you are catering towards? And then based on that, the agent will decide whether to disqualify the lead and move it into just system of record, which is like HubSpot, or to actually assign it to an account executive so that they can follow up with the lead. So that is a good example of an autonomous agent. And let us see how it works here, right? The query coming in, and in this scenario, instead of a human asking for a query, it is actually the hubs a Booker form, Booker demo form entry that happens, and then the LLMs comes into picture. They can search for internal guidelines, which tells them how to qualify the the particular opportunity, and eventually they complete their action, sends it back to the interface. And here it's instead of an interface, it is going to send the call to a second agent, an agent that can assign to an account executive. So this is how autonomous agents are work. I mean, work. Sorry, they are either triggered by an event. In our scenario, the event is book a demo form, or they could be triggered by a time, right? Imagine if you want an agent that sends a report 8 a.m. every day. So that is a time-based trigger. So we have various triggers, but the most popular ones are event-based triggers and time-based triggers. So autonomous agents will be far more, I would say, mainstream, if not already. But you will see a lot more autonomous agents being mainstream, sending you, doing tasks for you on a continuous basis. They'll work like an alarm. LLMs like free-flowing chat GPT and Claude, etc., they become far more useful in an organization setting when they are enabled with RAG as an option, a retrieval augmented generation, right? So how does RAG works? when someone asks a question, imagine when someone says, "Hey, how do I um, how do I handle an MCB trip, for example?" So that LLM will have a knowledge and they'll be able to answer. But if I'm asking the same question, if I'm a technician or electrician asking a question within a power plant, "Hey, I don't know. I mean, this is the equipment failure. How do I handle it?" GPT may not know the answer because the data might be very specific to that particular power plant, and which is where it will query results by looking into the database, and it may even call some external tools like third-party systems to find additional data if required. And then it also obviously stores in its memory if enabled, and then you get the output. So these are the actions that an LLM would take, and that's why an augmented LLM is the first step of an LLM becoming an agent in itself. And the whole concept of RAG was made super popular by probably Llama Index to begin with. And you can see how they are fundamentally different from the semantic search, right? Because in RAG, what happens, they combine the LLM's capable, I mean, context with the external data, the data that you supply from your internal knowledge sources. In the example that I gave, the manual of the power plant itself. Wherein in semantic search, the LLMs were not available. You'll do a kind of a k-means and I mean to find out figure out nearest information that is available from the data. It was the previous model that we used to extract data, but RAG has fundamentally changed the way you can query via natural language from a large data set. And moving further, doubling down into how RAG actually works, this is a very beautiful workflow explaining the step-by-step process. Imagine, say, if you have 20 different PDF documents. The very first step is chunking. Your PDF documents will be chunked into smaller set, like say 1000 words or 500 words, etc. So smaller chunks with some overlap. The typical overlap is 20%, recommended overlap. So a 1000 word chunk would have a 200 word overlap with the next chunk, and then so on. So these chunks go through a choice of embedding that you choose. It could be OpenAI, which is the most popular one. And then those embeddings are stored in a vector database. Now, when a user comes in and asks a query, like I mentioned, "Hey, show me what is the equipment error in this scenario? Can you give me some more details?" The user query again is used by the embedding model to convert into vectors, and then it's going to search for similar top case similar documents to try and understand what could be the possible answer for the question that you asked. And that is then sent to the reader finally, where the context is collected. And LLM, now this is where LLMs really come in handy, right? So if you see this whole process, we've been using embedding models, which is obviously LLMs, but the actual usage comes here. Now, LLMs are looking into all of the top case documents. Now it has to make sense of what is the user query and what is the document that I have and how do I come up with an answer. So LLMs come up with an answer. Again, the next best word prediction works beautifully here. And then you are able to generate the answer. So this is how RAG works. Very, very simple. Now, there are a few techniques. Like, for example, if you look at Lyzr today, Studio, and if I go to knowledge base, hmm, I have options like this. Okay, MMR and HyDE. What do they mean? So these are additional options that are available, are various different retrieval techniques available to further enhance the accuracy of retrieval. So MMR stands for maximal marginal relevance, and HyDE is hypothetical document embeddings. So they allow you to handle the diversity that is there. So let me give an example of HyDE, for example. If you look at this scenario where your top K similar documents are generated, now instead of LLMs just trying to use your user query and top case similar documents in order to find out what is the answer. HyDE is where the LLM will generate possible answer to the query. Like if I ask, hey, this is the equipment error that I'm facing, can you tell me what's wrong? So instead of LLMs trying to search for an answer from the embeddings, it will first create a possible solution. Okay, you are facing this equipment error because of so and so, because of this failure or a particular alert. Now it will take that answer and query combination to search for answers from the vector database. That further increases the accuracy or relevancy of data that is extracted. So that is one of the advanced retrieval mechanisms that you could try. So similarly, there are various ways to mix and match. So you can increase the number of chunks, you can increase the score threshold and play around and retrieve. So long story short, your basic retrieval itself is quite powerful by wherein you can try various mix and match before even looking into graph rag and agentic rag. So I hope you understand the concept right now. Today, let me share what we are seeing from a practical point of view, right? Almost 80% of all the production workloads today do not need agentic rag. They do not need graph rag. What you see here is absolutely sufficient. That is the current nature of the agents and the problems that are being addressed with agents today and RAG today. And thanks to vector database, which has made all our lives easier, as you saw, vector databases store these vector embeddings, and when you query the result, it's able to do the top case similar documents, and so the scan is the one of the algorithms that it uses in order to pull the relevant answers. And today there are several leading vector databases. Our favorites are Qdrant and Weaviate. They have their strengths. And PG Vector, Mongo, Chroma, there is, I think, Lyzr. There are a few others which are also around, but if you have to just close our eyes and recommend, we would say Qdrant and Weaviate are probably moving up the ladder. There is Pinecone for from a speed point of view, but I think organizations are now very clear that speed alone is not sufficient. There has to be an optimization between cost as well and speed. So Qdrant and Weaviate works pretty well. Now, moving on to various different RAG approaches, we saw naive RAG, which is what you saw, right? Like just throw in some documents, have some chunking, use an embedding model, and start retrieving data. And then the advanced RAG is where the HyDE and MMR approaches comes into picture. Now we are entering into the world of agentic RAG. So agentic RAG is where it's not one retrieval that happens from your system. Rather, there is a bunch of retrieval. There's various retrievals that happens on your system, like parallel retrievals happening on your system, and it's also multi-step. So there might be a retrieval from your knowledge base or vector store. Then there is another agent that is reviewing it, and if it is, say, not happy with based on the parameters, it can send feedback and retrieve further data. So it can go into loops until your criteria is met. So that is agentic RAG, and we'll see with an example. Multimodal RAG is still an emerging concept where you can now have mixed media data like images, text, etc., not just text alone. Very useful when it comes to, say, image matching or pulling in details or analysis about any of the images that you may upload. And then the even more advanced concept is the graph rag. Graph rag is nothing but retrieval augmented generation on a graph database with alongside the vector database. The index is still stored in a vector database, but the entity relationships are stored in a graph database. And graph rag is becoming popular of late because they can handle complex relationships between documents and datasets that you have, and they automatically do multi-hop reasoning you don't have to have agentic RAG per se. They already have multi-hop reasoning because they're already looking at the entity relationships, the ontology that is created during creating while creating a graph, right? All of that comes into picture. So the multi-hop reasoning happens within a graph itself, and it is highly scalable compared to a vector data store, and it also can handle multimodal pretty efficiently compared to vector databases. And finally, GraphRag, since it is by default agentic in nature, you're able to not only get an answer, but also the reasoning path, right? Okay, why did I get this answer? What were the various nodes that were considered when it comes to answering this question? So long story short, GraphRag is a lot closer to how we humans process data because we just connect the dots and then we try and figure out what may be happening. That's exactly what happens behind the scenes with a GraphRag and an organization. So where do they apply today, right? If you look at from an application point of view, traditional RAGs are fantastic for short FAQs, and GraphRag comes into picture where you have to retrieve accurate data from thousands of files. Think of a procurement team where they have, say, 5,000 different contracts and they want to extract far more accurate data. An agentic RAG comes into picture where you want agents to extract the data, analyze them, send feedback automatically to the extractor, and extract newer data based on the feedback, and it goes into loop until you get the desired output. So these are the three primary use cases. If I have to just on a high level, if you think about it, agentic RAG is where you have some sort of autonomy, where you are asking agents to reason and come back with the right answer. GraphRag is primarily applicable for vast amount of data where you also need high levels of explainability and accuracy. And traditional RAG is the fastest. There is no latency, less latency rather, I would say, and you're able to train something quickly and start moving forward. So that is traditional RAG. So these are, again, like I said, horses for courses. 80% of the use cases today are handled today with traditional RAG. You don't need graph RAG or agentic RAG. With that, we are getting into the next aspect, tool calling. But before tool calling, let us actually build a RAG system, right, on Lyzr. So one of the key things that we continue to focus on the Lyzr side is we want to make it easier for anyone to create a RAG, a knowledge base. So let us create one. I'm going to create a new group, say Agent Architect Cohort 2. Okay, failed to create a group. Oh, okay, create new knowledge base. We don't have to create a folder. There is still a beta version. So we can create a knowledge graph by adding your Neo4j credentials, or you can also create a new semantic data model where if you want to say handle CSVs or databases, but I'm going to create a knowledge base here. So Agent Architect 2 sample KB created for Agent Architect Cohort number 2. And like I said, you can choose any vector store. We give you these options. So I'm selecting Qdrant by default. I've added the other one is something that I've added myself. So create. Now we have the knowledge base created. Now step 2 is for us to upload documents into the knowledge base, right? So I can upload or I can give a website URL. So let us go to, say, Paul Graham essays. That's kind of the gold standard that all of us try and use it. Let me see if we can scrape the whole thing. I'm going to upload, enter website URL, max crawl page 1, crawl depth, I'll probably give 10. So how deep the crawler should go through the website links, right? And how many number of pages would you want to crawl from the website? I'll also give 10. And dynamic weight is so that it doesn't time out quickly. So we are also updating these settings so that you don't have to go through all of the technical stuff. So upload. Now the agent will go through pulling some of the data. It has just picked the main page. Let me ask a question. What essays say speak about sales? All right, let's try this. How to do great work, having kids around. This is if you're not sure to which to read. So I think we didn't scrape the whole page. It is just pulling the top data only, just this part of it. So we can obviously go and probably add one more data set, the shape of essay field, or rather I'll take a different one. Good writing. All right. So upload, give the website URL. Okay, so we have another article that is trained now. So we'll say summarize what good writing skills are. So we can see the accuracy now, 82, 80, and 76. And you're able to see the chunk. So basically what happened in the back end, there were chunks that were made, and you're able to see the chunks that um, answer or comes back with a better retrieval. Now, these are all retrieved chunks. These retrieved chunks from the knowledge base will have to be used by an agent in the front end in order to make use of it. So let us now create an agent, right? I want to create an agent, say good writing by PG. I'm giving the same description here, selecting a base model. I would say you are an expert retrieval agent. And I would say your goal is to address the queries accurately. And here I would just simple instructions, right? Um, Understand user query, retrieve the relevant answer from the knowledge base, and share a short summary. Simple instructions. I'm enabling knowledge base now, selecting the one that we just created, Agent Architect 2, save it, and create. Agent is ready. So we can ask the same question here. Summarize what good writing skills look like. All right. So yeah, it's picking from the knowledge base, and you can further improve it by reducing hallucinations, by enabling reflection, etc. This is something we'll see on day 4, because these are all the productionization aspect. How do you make a simple agent into much more production grade agents? And we can again we can start chatting more. I can enable memory now, so the agent remembers what I asked. I'm going to clear it again. What, according to Paul Graham, is a must-have feature in when it comes to good writing? It should sound good. So yeah, this is how you can build your own knowledge base and start interacting, right? Like if you have an organization, if you're at an organization, if you want to build a chat bot, just download the FAQs or share the FAQ page with the agents. The knowledge base will scrape it and create a FAQ list for you. And then you can launch that as an application instantly, or launch that as an agent to your application. So that's how easy we've made to build a knowledge base. But again, for advanced scenarios, we recommend using a knowledge graph, and for more structured data queries, we recommend using a semantic data model. So these are concepts that will go deeper on Thursday for you to interact directly with CSV files, etc. Let's move on move on to tool calling now. So we saw how knowledge base is giving context to an agent, and that is the whole concept of context engineering. From there, we are moving to tool calling. Tool calling makes the agents far more useful in the real world scenario. You don't want to be the bridge between your Slack and Notion to your agents. You want your agents to automatically interact with these tools. so that they can get stuff done, which is where tool calling comes into picture. And the best part is LLMs can natively call tools. All you have to do is just give them simple instructions on how tool calling should be done. So let us look at this example, right? So if imagine if you say, okay, give me electronics between say $10 and $50. Now the model has its instructions internally, and it does a tool call, and there's a tool invocation happens, and then you're able to get the results. But what happens behind the scenes, there is a database, and the database is exposed as a tool. So the model is able to use the instructions and the connected tool and extract the relevant data, and then it gives you the output. So the tool calling is super simplified because LLMs can take natural language instructions and use them effectively for tool calling. And the evolution of API-based tool calling in the LLM world is MCP's Model Context Protocol. But before getting there, let us look at how tool calling works in practical scenario, right? So we have Lyzr has all the tools, and you can integrate tools that you want to use just by clicking them and authenticating them, or you can also add your custom tools that if you want. Once you enable the tools that you would like to use, just go to the agent and select an agent that you want, say Lyzr Prompt Improver, for example. And I can go to the tool configuration and add a tool. Okay, I would like to use, say, Perplexity. And how do you want to use the tool as an example, right? So that's how you can add additional tools, or I can say, you know what, I would like to add my Gmail, and I would like to send these output to my Gmail. So these are additional scenarios how you can add your tools, and it's pretty simple instruction calling that you have to do here. I'm not sure if the team is pushing something to the tools, but we'll check on it. So tool calling, like I said, LLMs can handle it natively. You just have to add them and give the instructions that you may need for tool calling. Now, moving on, and again, in an enterprise setting, you have options to add custom tools. If you see, we followed OpenAPI schema, so you can literally add any custom tool that you may need within an enterprise scenario. So finally it loaded. Yeah, so I can authenticate. My Gmail is already connected. I can also add a Perplexity key and enable it. I can enable Slack as well. Mine is already connected to Slack and Notion and so on. So the tools are available, and you can just call them and start using them by providing additional details. Now moving on to tool calling. Tool calling was very popular, but MCP came into picture, and they really changed the way we interact with these APIs. So Model Context Protocol is a dynamic way of calling tools or third-party services in a client-server model, where the MCP client invokes the tool, and they query for what all resources that the tool could provide, and then it interpolates the prompts. On the other hand, the MCP server exposes the tool, and it exposes its resources and also the prompts. Let us take an example, right? Lyzr, if you go to again Lyzr is available as an MCP server on top. Here we built an MCP server, and Lyzr agents are available. And what we've done is we've exposed, like you see here, what all you could do with the Lyzr agent. You can pass a data to it, and you can retrieve the data from it. Very similar to LLM, because it's a two-way street that we've done at an API level. And all you have to do is now in an MCP, what happens? The logic of how you want to use the tool, how would you want to use these resources, or again in simple natural language. So when you look at the tools, the functions are invoked by the model. It could be retrieve, it could be a search, it could be sending a message, or it could be even updating a database. And the resources within those tools could be, say, files for that matter, or database records if it's a database, or API responses in case of Lyzr. And then prompts is where you are defining what you want to do with the tool. I want to transcript the summary by reading into the Lyzr's say research agent, or I want you to build a Q&A by looking into all the files that you have in a particular Google Drive folder. So this is how the prompts come into picture within an MCP. And for that reason, MCP is still not highly deterministic because you're again using a large language model to decide on the fly on what should it do with the tool. When it comes to highly deterministic workflows, we still recommend you to obviously integrate using APIs, the OpenAI standard that we have published, but otherwise that we have built on. But MCP is a faster way to get there. And if you think your workflow is not very deterministic, then you obviously can break it down and use APIs. But all this comes into picture for a developer. If you are a no-code builder, don't worry about all of this. Focus on how you're going to use a tool whenever required, right? Tool calling should be just, and we are seeing this again, almost 60 to 70% of the agents that are built on Lyzr has only one or two tool calls, and they're also very standard tool calls like Outlook or Teams or Slack or Gmail. Very standard tool calling, nothing fancy to be honest. Most of the work is done by adding a knowledge base to an agent. So you don't have to necessarily worry about MCP and A2A and other scenarios. They are cool concepts, but not necessarily applicable in a lot of scenarios. And if you're a developer, you do have the liberty of customizing or building custom API or integrating via API, making the systems a lot more deterministic as well. Now, this is another good representation of MCP server, an easier way for us to understand, right? Like take Lyzr, for example. Lyzr is represented as a MCP server, similar to Slack or Gmail. And then MCP acts like a hub where it connects to the clients. Now, from your Claude desktop, you can call a Lyzr agent saying, hey, I want you to generate a new prompt for me. So Claude Desktop via the MCP will reach out to the MCP, Lyzr MCP server of that particular agent and get the job task executed, and then it is able to return the output. So this is how I would say MCPs are becoming popular today. No wonder the most popular MCP is GitHub server, and as you see, it's a very developer friendly, I would say, service today. We are not necessarily seeing a lot of practical application in the semi, I would say, developer or the no code world. An extension of MCP further is A2A, where the communication is now handled or normalized between two heterogeneous, even homogeneous or heterogeneous agents, right? Like Lyzr to Lyzr, agent communication is something that Lyzr has built as a protocol. Similarly, LangGraph agent to agent, LangGraph has built in their orchestration and agent handoff. But what if Lyzr agents have to share data with a Google agent, or Lyzr agent have to share data with, say, an Amazon agent or Salesforce agent, which is where A2A comes into picture. This is a standard that Google established, agent-to-agent communication. Again, practical application, probably less than 1% at this point in time. Even if we integrate with, say, an agent force agent, they don't expose all of the data via the agent. It's highly restricted anyway, the kind of data that those agents hold. So not necessarily super useful, um, the kind of agents that these large enterprises launch, especially not useful from an integration point of view, and because they want to protect their data, keep the data among themselves. So A2A is still an emerging concept. Probably, I would say the full, I would say, power of MCP and A2A might be realized next year or the year after. A2A might be even further. And we may get even more protocols by then. MIT launched Nanda. Lyzr is a launch partner of Nanda protocol. Again, it's an agent-to-agent communication. I think Red Hat also launched one. So there are a few agent-to-agent protocols, but again, we're not seeing practical application today. We are still in, I would say, innings one of the whole agent adoption. And this leads into another interesting concept called agent mesh. All these agents are collecting tons of logs and data, as you may see. But what if these logs, which are small intelligent bits basically, what if all of this write into a central mesh where a collective intelligence is being built in, which allows the overall ecosystem to improve? So one of our teammates, Jeremy, built a beautiful illustration to show this. I'm going to bring it up. So this is a visualizer of a banking system where there are multiple agents that are working with one another, executing tasks, sharing data with one another. And what you're seeing here is a knowledge graph that is continuously writing into or a combination of agents that are writing into a central knowledge graph. Thereby, the overall intelligence of the system keeps, I would say, evolving. And it now comes down to the builders like us to figure out how do we extract intelligence out of it. Can we navigate into the knowledge base that is built in the backend and identify new patterns that otherwise we may not be able to track? Can we correlate data between, say, a customer support function and a product function and unearth trends that we may otherwise not know, or we may don't. I mean, our human team may not be able to even comprehend the kind of correlation that these agents could do. So that is the direction where agent mesh is taking us towards. Again, a technology that we are working on as a company and planning to launch it shortly. So these are all possibilities. Again, like I said, MCP, A2A, agent mesh, all these are very early. 2026, 2027 is where probably we will see a lot more usability of these platforms. And with that, we'll get into the final, I would say, topic today, which is voice. Voice is probably one of the biggest application that generative AI has brought in. I mean, I don't even, I think I type less and speak more. The next step to voice is neural, which is the final frontier. Hey, what if I can save my energy and don't even speak? Can I just think? And then we have all the prompts appearing, right? So that is the direction that some of the startups are trying to get there. But voice today is the place where we're able to fully unleash the Gen AI as a beast. So how does it work, right? Building a voice agent starts with the core being your agent itself. Let me show that with an example. So here I have built a life insurance agent, claims agent, and the core is the thinking process, the core agent itself. So I'm saying, hey, your role is you're an expert claims data collector. Your goal is to collect all necessary data regarding a claim with high levels of empathy. Because we're talking about life insurance, people will claim life insurance when there's a death in the family. So we are saying agent be empathetic. And all the instructions that you want to give to the agent. Introduce yourself and tell them you're sorry for their loss and so on. So if you see the brain of the agent, of a voice agent, is still the core agent itself. And all we are now doing is just lending voice to it. So I'm gonna lend voice to this agent now. And we used OpenAI, and in production, this is a preview, but in production, if you see, you can bring your own, say, 11 Labs or DeepGram key, and you can enable voice. So you're still able to control the thought process or the core thinking with the agent itself. So let us go to voice, right? Hi.
Hello, and thank you for. I'm very sorry for your loss. My name is Hudson Life Insurance Claims Department. Before we proceed, may I have your consent to continue with the claim process?
So if you see here, it said my name is Hudson which is not an LLMs don't think. So let me go back to the LLM and give it or improve the instructions. So this is how you can improve on a continuous basis. Introduce yourself an AI agent um, representing Hudson Life Insurance. Your name is, say, Sarah. Save, update. That's it. We have improved the agent's core instructions. Let's go back. Hi.
Hello, I'm Sarah, representing the Hudson Life Insurance Claims Department. I'm very sorry for your loss. Would you like to proceed with filing a claim? Please let me know if you're ready.
Yeah, I'm ready.
Thank you. I've just sent a link via text where you can upload the claims form. Could you please confirm once you've uploaded it? After that, I'll ensure that we handle your case swiftly and get back to you with the status in 24 hours.
Yes, thank you.
You're welcome. Again, I'm truly sorry for your loss. We'll review the uploaded claims form and contact you within 24 hours if we need any additional details. Hudson Life will work diligently on your case. Take care.
Thank you so much. So if you see there was an issue here, I just have to go back to the brain of the voice agent, which is the core agent itself, where I was able to change the instructions quickly and then go back to the voice. And this need not be a single agent. Obviously, it can also be a multi-agent system like this, where your voice agent could be one of the agents, while the other agents still get to do their job. So this I would say 2026 is going to be very big with voice. We're already seeing that in 2025. But 2026 is where the autonomous nature of agents will require more voice integration in the systems. And obviously, you can supply knowledge base to the voice agents in the backend, ensuring that the agents just work within the context that you provide. So that brings an end to our day two. Again, we want to keep it short because there are many other concepts like agent eval and etc., which we would want to cover later. But the focus here is to really double down on the key aspects, which is the knowledge base and the tool calling itself. Tomorrow, very big day, orchestrations. And I'll show you a glimpse of what we mean by orchestrations. At Lyzr, our thought process is that, hey, you need to see how agents are working in the backend. So this is what it's in store tomorrow for you. You will be able to see the agents in action in real time. This is a managerial orchestration. Like I said in yesterday's session, almost 80% or even 90% of all the workloads could be handled by managerial orchestration. Now, when you shoot in a query, um, you will see how the agents are called in real time. So there is this agent processing, and then it hands off to the other agent and so on. So it's happening in real time, and you'll be able to build it yourself tomorrow and get firsthand experience on building managerial orchestration. It's super fun, to be honest. Once you start building, you will want to experience more of it. And about the thing about Lyzr is we made it again super intuitive and super transparent for you to see what's really happening behind the scenes. So you're able to really appreciate what these uh, agents do in a managerial setup. Okay, with that, we'll get into questions. Again, tomorrow is a bigger one with a lot of value unlock happens during practicals, and tomorrow we're going to start practicals starting with orchestration tomorrow, mostly the managerial and some sequential. Day four is when we'll get into the production grade, I would say, features like. Again, we'll look into knowledge base again, graph RAG. We look into tool calling. We look into responsible AI features and how to use them. And then day five is where all of this comes together. Can we build a Y Combinator grade end-to-end application with Lyzr and Lovable? So with that, open to questions, team.
Okay, Shiva, there are a few questions in the chat. So one question is, can we use Lyzr voice agents for customer calls?
Yes, you can. You can integrate with Twilio, and you can obviously use for customer calls, either Twilio or any IP-based system. If you go to Lyzr.ai website, you will see our phone agent, Lyra, and you can obviously call her on a phone and you can speak. So yes.
And there's one more question. Was Agent Sam developed as autonomous agent? I took a look at it today and it looked like it was autonomous.
Autonomous in the sense we obviously trained it on a knowledge base so that Agent Sam doesn't answer things that it doesn't know. And customers can, I mean, our VCs can obviously interact with Agent Sam and really understand more about our business so that they can decide to invest. So it is built as a standalone autonomous agent with a knowledge graph built in, and there is no supervision there.
Okay, Jeff has a question. How do we build RAGs and knowledge bases that are proprietary IP to ensure their info isn't shared with training data?
Yes. So several enterprises are building knowledge bases or knowledge graphs in their own cloud, be it Amazon, Azure, or Google. And if you see in Lyzr, we have option for you to add your data store. So you're just adding data store wherein only a small amount of data is shared during the inference time, which the agents use for that moment. So yeah, you have the option to add your own data store, keeping all the data with yourself. Yeah. Again, tomorrow is going to be the big day. Today, the first 2 days were all about covering all the basics so that as you get into start building really useful agents, um, you need to know how the basics work. Now that you know all of them, the next 3 days are going to be clearly orchestration, productionization, and the build, right? How do we build a YC grade startup in like 90 minutes? So that's the direction that we would take as we move forward. Um, don't miss tomorrow's because, again, for you to think about automating a lot of processes internally, the orchestration is pretty important.
Hi, Shiva.
Hi, Gautam.
I have a question about voice agents. I have used it and noticed that one STT and one TTS model is currently offered, DeepGram and 11 Labs. But if you have to, like, if you want to use other models, do you plan to offer additional models in the future, and especially some of the Indian voices as well? Because there are some scenarios where we need some Indian voices. I mean, 11 Labs is good, but in case we want to use models like, let's say, Sarvam, do you plan to increase the number of STT and TTS models?
Yes, and that's the plan. We want to start with the most popular ones, so that you start building your agents, train them, and eventually, when it comes to switching to other voice models, we can take the request in. So again, it's just prioritization. But short answer is yes. The idea is to integrate other voice models to give a better, I would say, more options to our customers.
Yeah, sure. So hi Siva. One question I have is now that you are training all of us as architects on this technology, apart from being able to do something like Y Combinator level for our own use, are you planning to kind of do crowdsourcing and throw some challenge at us and utilize it in a way where we can contribute to Lyzr itself?
Yeah, a good idea. We were thinking about making you fully aware of how to do end-to-end application build out, right? Where we want it's more of still a shadow training scenario where our solution architect Jeremy and our core platform engineers would be joining to build something so that you can just do a shadow build with them. And we want to run this challenge post the training, post the 5-day cohort, so that you can then build something and submit for everyone in the community to see what you built. But the thought process, again, this is based on the request that we had from the previous cohort as well, that, hey, don't throw us a challenge on day 5. We're not ready yet. We rather want to shadow you and build something. So that's the thought process.
Yeah, makes sense. Thanks a lot.
Thank you.
Okay, Shiva, one really hot question even on the circle. People are asking, how do we get more credits for testing?
How do we get more credits? Yeah. Obviously, you can top up. This is a shorter answer. Please understand, we do pay to OpenAI and others. But what I would recommend is, and we've seen this happening quite a while, right? Don't use very expensive models like GPT 4.1 or other models, because Claude is, like, I would say the super expensive is Claude 3.7 and Claude 4. You will spend a lot of credits so quickly. GPT 04 or GPT 4.0 mini is still fantastic. Google Flash 1.5 is still very strong model, to be honest. So we would recommend using those, because you can actually save tons of credits on the platform. You don't have to, you won't need additional credits actually. But we will look into how we can probably increase the number of credits as well, from 500 to probably 1000. We'll come back to you on it. We'll look into that. But first, my default suggestion would be to use smaller models. They still work very well. For, like I said, 80-90% of use cases, you don't need heavier models.
Shiva, one follow-up question to that. People are asking, if we have our own API keys, then how does the credits apply there?
Yes. When you bring your own model API keys, we have a flat pricing instead of a variable pricing. If you use models from Lyzr, your credit usage will be based on the heaviness of the model, right? Costlier models, you will consume more credits. Cheaper models, you'll consume less credits. But if you bring your own API keys, it's a flat pricing. It doesn't matter whether you use a super costly model or a regular model, like a base model is GPT-4o for that matter. So you will eventually spend less credits if you bring your own API keys. And you can add that via adding your own model. Great. So again, thanks for all the questions, team, today. The next 3 days is the real step up, now that we've understood the concepts. And let's get this moving. Last question I'll take: is there scope for using open source models in Lyzr? Answer is yes. We are launching the Ollama integration shortly, so you can use open source models. Today, via Grok and other platforms, you still have access to open source models. But via Ollama, you can now add your own open source models as well. Thanks, team. Thanks again. We'll catch up tomorrow, same time.
Thank you, Shiva. Thank you, everyone, for joining. See you all tomorrow at the same time.